Hello everyone. In this video, we will be presenting a 3D convolutional neural network for COVID-19 assessment on CT scan images. We will first have a small introduction that consists of the problem we have and the proposed solutions. Right after that, we will discuss some solutions using AI. We will also get into our approach for COVID-19 detection using 3D CNN and introduce you some of our results. We will conclude our video with a recap to all what we have seen so far. The number of contamination of COVID-19 in the world has widely and rapidly spread, and this histogram describes the number of infected and recovered people in the US, India, Brazil, Russia, France, and the UK. As you can see, there are more than 35 million of infected people in the US, while there is less of 30 million recovered people. This large spread of this disease puts us in a situation where we find ourselves obliged to search for methods that are fast and specific, yet not very sensitive. There exist four methods of COVID detection so far, which we divide into two sections. First, we have the imaging tools or thoracic imaging tests that consist of chest X-rays and CT scan images. Secondly, we have the genetic tools that are RT-PCR tests and rapid antigen detection tests. RT-PCR are not very effective before the first 3 days of infection, and they are very time-consuming, which may help the spread of the COVID-19. Rapid antigen detection tests, on the other hand, are faster yet not very accurate, so we look for even better options. Chest X-rays are also faster than RT-PCRs, so we can say that imaging is more cost efficient. Sadly, chest X-rays are not very specific to COVID-19 and may overlap with other infections. That leaves us with the last and only option we got, CT scans. CT scans are better diagnosis tools since they provide a detailed structure of the lines in 3D and allow us to observe the most significant lesions. Due to several challenges faced by healthcare practitioners in COVID-19 detection, AI researchers decided to help make a fast and accurate tool to help diagnose patients, highlighting critical thoracic regions. This problem caught many researchers' attentions, so many works and articles have been proposed. We introduce some of these works in this table. The first approach consists of transfer learning applied onto the architecture model of 17 layers. This model outputs three classes: COVID-19, pneumonia, and no findings. Ahuja et al. Proposed a 2D architecture model with 71 layers using transfer learning on ResNet 18. And it outputs two classes, COVID-19 and non-COVID-19. Rizaul et al. Proposed a transfer learning ensemble model using VGG19 and DenseNet 161. Four classes are outputted: no findings, bacterial, non-COVID-19 viral, COVID-19 viral. Basu et al. Proposed a 2D architecture with 12 layers, where 6 convolution layers and transfer learning. It also outputs two classes, COVID-19 and non-COVID-19. Jin et al. Proposed 152 convolution layers using transfer learning, and it also outputs two classes of COVID-19 and non-COVID-19. Our approach is a 3D architecture with 17 layers using transfer learning. Our model have been used on tuberculosis, dataset. It outputs two classes, COVID-19 and non. In our approach, we use 3D input images to preserve the spatial information of the volume by reducing the preprocessing of the images, speeding up the learning process, and by adjusting the complexity by reducing the number of parameters. This model was mainly inspired by the deep network that uses 3D volumes of CT scans versus no finding images. We retrained the model so it classifies images of COVID-19 and non-COVID-19. This figure describes the overall architecture of our approach. The collected data will be passed in two phases. First, we got the pre-processing phase. Those pre-processed images will be passed to the training phase so we can obtain the trained 3D CNN model. When the user tries to test a new image, it also passes by the pre-processing phase. However, it will be passed directly to the trained model. So it gives us a prediction result that is the probability of the two classes, COVID-19 and non-COVID-19. The datasets we use for training and validating are open source datasets collected from Russian and Italian hospitals, while the dataset used for testing is collected from the Algerian hospitals. These datasets are in Nifty format. In the pre-processing phase, we got the transformation of the data by normalizing and resizing it to be 128/64 using SIZ. Right after we split the data into 70% for training and 30% for validation, we also augment this dataset by rotating the images with random angles between -10 and 20 degrees. The model consists of a classification block that has 4 blocks of 3D convolution layers followed by 3D max pooling layer and batch normalization. We also got a classification block with a flattened and dense 512 layer followed by a dropout and softmax activation layer that gives us two outputs for COVID and non-COVID. Why did we use 3D instead of 2D CNN? Simply, 2D CNN will strongly degrade the performance of the model, while 3D CNNs exploit simultaneously the geometry of the volume. The parameters we use to train this model are 100 epochs, loss function binary plus entropy, early stopping callback 15, learning rate of 104. We used Adam Optimizer and batch size of 2. For evaluating our model, we used a local dataset annotated by experts. We got a recall of 1, and F1 score of 88%, and accuracy of 80%. Here, we introduce to you the technologies and the API. We used Cargo Cloud for training the model. We used Keras library and TensorFlow library. We also used Django framework for making the API. For a better result and understanding how our model performs and classify COVID-19 images, we thought of adding a 3D heat map algorithm to highlight regions where our model predicts lesions. To conclude our work, we talked about an automatic diagnostic that we proposed using a deep learning algorithm. The proposed model is less able to identify CT scans of healthy lungs. More data from diverse resources is necessary for further evaluation. The model acts as smart medical assistants to help medical practitioners in COVID-19 detection. Here, we leave you with some references.